The remaining functional groups in this chapter are aldehydes, ketones, thiols, and sulfides. These are all biologically important functional groups.
Ethanol is a primary alcohol. Because it is a primary alcohol, it is oxidized in a way that we have just seen. Alcohols that are primary can be oxidized to aldehydes and then to carboxylic acids, and that's just what your body does when you consume ethanol. The first step in the oxidation of ethanol is it forms an aldehyde, and it's called acetaldehyde. Then your body will oxidize it further to acetic acid. Now, what's interesting is when you consume too much ethanol, it's toxic to your nerves, and then you see that your nerve function is reduced. In fact, you can reduce your nerve function so much that your body stops functioning and you die. If you consume too much ethanol, your body will start to metabolize it as a carbohydrate, and it oxidizes it relatively quickly to acetaldehyde. The acetaldehyde then is oxidized in a little bit more slower fashion to acetic acid, but buildup of acetaldehyde is not good for your body. It's toxic, and that is what is responsible for the feelings of a hangover, of feeling sick, and also being sensitive to loud noises and various things. Thiols are just like alcohols, except for instead of an oxygen, you have a sulfur in there. They cannot hydrogen bond, so they are not very soluble in water. And what the most remarkable characteristic of thiols is that they are incredibly foul smelling. They smell, thiols are responsible for the odor of skunks, for many of the smells that you find in garbage or in sewage. They are named just like alcohols, but instead of saying ethanol, we name the alkane, like ethane, and then we end with thiol. So the thiol that looks like ethanol is called ethane thiol. The group is also called a sulfhydryl group. I am not going to ask you to name any thiols, just to be able to recognize them from the name or from the structure. Right here is a thiol. This is ethane thiol. And you can see that when it's oxidized, it does not undergo a reaction like the primary alcohols, but instead what happens is it causes two thiols to join together in a disulfide. And so two ethane thiols, when oxidized, become a disulfide with a sulfur-sulfur linkage, and when it's reduced, it goes back to the thiol. The disulfides are important because when we start looking at proteins, we will see that that disulfide connects one part of a protein to another so that it folds in a particular manner and gives it a very specific three-dimensional shape. When you have curly hair, it is usually due to disulfide linkages between proteins in your hair so that it holds it into a curl. And when we have permanents or straighteners put in our hair, they take advantage of this reaction. And basically, when you are doing a permanent or a straightener, what they do is they first reduce the disulfide linkages, curl the hair or straighten it to a particular way, and then they oxidize it back to disulfides to hold it in place. Aldehydes and ketones have the same functional group, that carbon-oxygen double bond, and we call that a carbonyl. The difference between aldehydes and ketones is that aldehydes have the carbonyl on the end of the chain, and ketones have the carbonyl in the middle of a chain. Or you can say this, that an aldehyde has a hydrogen attached to the carbon in the carbonyl, And in ketones, there's 2 carbons attached to the carbon in the carbonyl. The carbonyls have a very large dipole of a del positive on the carbon and a del negative on the oxygen. This makes them polar, and they are somewhat hydrophilic. They can cause a molecule to be dissolved in water, but they do not hydrogen bond to each other, so their boiling points and melting points are not high. The polarity of that bond, as it says here, causes the melting point and boiling point to be slightly above that of the alkanes. But you don't have hydrogen bonding, so the melting point and boiling point is lower than that of the alcohols. There is no intermolecular hydrogen bonding, so this means that they cannot hydrogen bond to each other, but they can hydrogen bond to water, which gives them some water solubility. With aldehydes, what you do is you name the longest chain as an alkane. You remove that E from the end and add al. A-L, al. The functional group is always on the number 1 carbon in the aldehyde because it's at the end of the chain. And then you name and number the substituents. Let's look at an example. Right here, if I look at the longest chain, it is in blue. The longest chain is 6 carbons, so we say hexane. We take off the E and we add al because it's an aldehyde. And that carbon-oxygen double bond is the number 1 carbon. So now we count over and we see 1, 2, 3, 4. On the number 4 carbon, there is a methyl group, and then 5, there is another methyl group on the carbon. So the name of this molecule is 4,5-dimethyl hexanal. And then right here at the bottom, I'm showing you ethanal. Ethanal is ethane with an aldehyde group on it. But the reason I brought it up is I wanted to show you the common name, acetaldehyde. And you'll probably see that in various places. It's the same thing as ethanal. So now pause the lecture and go ahead and try to name this compound on your own. And then draw 4-methyl pentanal. Okay, this compound has the longest chain that starts at the carbonyl, that's carbon number 1, and then 2, 3, 4, 5, 6. You have to go to the end of the chain. One of those methyl groups is the end of the chain. So that's hexanal. The longest chain must have that carbonyl in it. Okay, so that's hexanal. Then we count to place the methyl groups. So you see on the number 2 carbon and the number 5 carbon, you have a methyl group on each. So it's 2,5-dimethyl hexanal. To draw 4-methyl pentanal, the first thing you need to do is put in 5 carbons with a carbonyl at the end. So 1, 2, 3, 4, 5 carbons with a carbonyl on the end, and then count in 4, 1 at the carbonyl, 2, 3, 4 to put on the methyl group. To name ketones, we do almost the same thing, except we're going to say "-one", and we have to put a number to tell where the carbonyl is, where the carbon-oxygen double bond is. That sets the numbering system. You always want to have the lowest number for that carbon-oxygen double bond, and then any substituents you're going to name and number. Be sure to put a number for where the carbonyl is in front of the name of the ketone. So let's look at some examples. For the first molecule, you can see that there are 5 carbons in the longest chain, so it is pentane. You take off the E and add "-one" for the carbon-oxygen double bond. I put a 2 in front of pentanone because the carbonyl can either be on 2 or 4 carbon. 2 is smaller, so I take the 2-pentanone. Then I find out which carbon the methyl group substituent is on, and it's on the number 4 carbon, so I put 4-methyl-2-pentanone. For the molecule below that, you can see there are 1, 2, 3, 4, 5, 6 carbons. So that's hexane. There's a carbon-oxygen double bond on it, so I take the E off and put "-one" on for hexanone. And then I count from either end and see it's either 5 or 2. 2 is lower, so I choose 2-hexanone. If I go to the next molecule, you can see that this is cyclopentane. I take off the E and add "-one, so it's cyclopentanone. The carbonyl is on the number 1 carbon, so the methyl group is on the number 3 carbon, and I call it 3-methyl-cyclopentanone. Go ahead and try these 2 molecules, name the first one, and draw a molecule for the second one. Pause and do these problems. For the first problem, you can see it is cyclopropane, so I take off the E and make it cyclopropanone. The carbonyl is on the number 1 carbon, so the ethyl is on the number 2 carbon, so we call it 2-ethyl-cyclopropanone. To draw 6,6-dimethyl-2-heptanone, I first put down 7 carbons, and I put a carbonyl on the number 2 carbon. Then I look and I find out where the number 6 carbon is, and on that 6 carbon I'm going to put 2 methyl groups. And so this is what it would look like: 6,6-dimethyl-2-heptanone. You might have drawn it flipped over, remember, but as long as the connectivity is the same, you have it correct. There are some common aldehydes and ketones. First of all is acetone, which is basically propanone. And that's something that your body makes, and those of you who use fingernail polish remover will know that some fingernail polish removers contain acetone. Formaldehyde has only 1 carbon in it. It's highly toxic, it's not good for you, and they use it for preservation in embalming fluid and in preserving things in bottles like embryos and things like that they don't want to decompose. Then acetaldehyde, I've already introduced to you, is basically ethanol. There is a ketone that is very common in your body. It's present in your body right now, and it's called acetone. It's the simplest ketone that there is, and when we break down fatty acids, acetone is produced. When you have a low concentration of carbohydrates in your diet, which sometimes happens with diabetic patients, then what happens is that your body tries to make more carbohydrates in order to have enough carbohydrates for all the processes that need carbohydrates. In order to make carbohydrates, they take fatty acids. Your body takes fatty acids and breaks them down into various compounds that can be used as carbohydrates, and acetone is produced in this process. There are other ketones or ketone-like compounds called ketone bodies that are also produced, and when you have a lot of fatty acid breakdown, you get a lot of ketones floating around in your body, and it is called ketosis because one of those ketones actually is a carboxylic acid. It actually will make you start having low pH in your blood, and it's called ketoacidosis. Aldehydes can be oxidized one step further. We've already seen this. Primary alcohols can be oxidized in the first step to an aldehyde, and then in the next step it is taken down to a carboxylic acid. Notice that in the step making the aldehyde out of the primary alcohol, there is a hydrogen removed from the oxygen and a hydrogen removed from the carbon. When we take an aldehyde and make it to a carboxylic acid, we're instead inserting an oxygen between the carbon and the oxygen. Notice that is what's shown here. So this is the second step in the oxidation of an aldehyde. There is an oxygen added into the molecule. Ketones cannot be oxidized though, because if you look at the carbon on the carbonyl, there is no hydrogen attached to the carbon on that carbonyl. And so what happens is it cannot be oxidized any further, and when you try to oxidize it, there is no reaction.